All right, on to the last example in this section. So, a school administrator is concerned about how much credit card debt college students have. She conducts a survey of 600 students and finds out that 195 of them have credit card debt of $2,000 or more. Okay, so first thing, what is the point estimate? So what is the proportion or percentage of students that she surveyed that do have credit card debt of $2,000 or more? So take the 195 students over the 600 students she surveyed, and we'll get 0.325. Ooh, hold on here. Making sure. Yep. Okay. Then construct and interpret a 92% confidence interval for the proportion of all students that have more than $2,000 in credit card debt. So again, she's looking at all college students, but she's only sampling 600 students. There's way more than 600 college students in the country. So the 32.5% isn't probably the exact value. We want to come up with that interval. So we're back to our one proportion Z interval test. We need the value of X, N, and then our confidence level. So X is those 195 students, N is the 600 students in the sample, and our confidence level in this case is 92%. So go ahead and get that all into your calculator. And we find, rounding to 3 decimal places, that the confidence interval is 0.292 as a lower boundary and 0.358 as the upper boundary, again with our 32.5% smack dab in the middle. And it also says interpret this, and so let's go ahead and start there. We'll make this a statistical interpretation. Okay, so there's a 92% chance the true proportion of college students with $2,000 or more in, oops, sorry, I don't know what just happened over there, in credit card debt is between, and I wrote proportion, so I'm going to go ahead and give this in proportion form, is between 0.292 and 0.358. Again, if you wrote percentage, then 29.2 and 35.8%. Okay, well, let's say, and this actually happens a lot, okay, the researcher wants to increase her level of confidence to 95%, and she wants to have a 2% margin of error. So you actually, like, researchers will do that. They'll say, I want to be 95% confident, and I'd like a 3% margin of error. What they can do is you can kind of back end it, and you can figure out how many people you have to sample in order to make that happen. Okay, rather than going out and collecting a bunch of data and then finding out you don't have enough, or maybe you have way too much, you can go at it from kind of the back door and go the other direction. So the formula you need, and actually I had you cross this out on the first page, and I did because we used it in the first section for a different purpose, but it's okay. Here it is, and I don't ever ask anyone to memorize this one, so it's all good to go anyway. Okay, so the margin of error is a Z value, okay, and I'll write down what some of those Z values are, or tell you how to find them, which is actually more helpful. Times P hat, so that's your proportion of, in this case, people who said they had $2,000 or more in credit card debt. Q hat, remember P and Q is like the opposite of that, so this would be the proportion that have less than $2,000 in credit card debt. N is, of course, the sample size. So let's see what this researcher's margin of error is currently. Okay, so with her current information, and we'll go back to the Z sub C value here in just a minute, P hat, remember, is the 0.325 that we got up in part A. Q hat is going to be 1 minus P hat. Again, the proportion of students who don't carry that much credit card debt, so 0.675. And then our n value is 600. Now, where do we get that z sub c value from? Well, I had you cross off a table in an earlier page. Maybe that was a little premature, although we aren't going to use it at that point. But we can use those numbers now. I can also review with you how we come up with those. It's not all that difficult, but depending on, sorry about that, depending on the confidence level, I can give you a few of those z sub c values just so you got them. And again, they're just back on page 6 of your note packet. Maybe don't cross them out quite as much. At 90%, the ZC value is 1.645. At 95%, it's 1.960. And at 99% confidence, it's 2.576. And I will give you a quick reminder of how that comes about. That confidence level, this is actually an inverse normal with a mean of 0 and a standard deviation of 1. That 90% or 95% or whatever, that's that middle, in this case, 95% that we're talking about. And whenever you do an inverse normal, you end up with this value right here being the 1.960. Okay, so that's where that comes from. If they ask you ever for any other confidence levels, you can come up with that Z value. So knowing that that's kind of where that comes from, and again, that goes back to some earlier information in chapter 6 or 7, our Z value is 1.96. I'm not going to write down the 0 because obviously it won't make any difference. Do go ahead and type that into your calculator, and you will find that the margin of error is 0.037 or 3.7%. So can she reach her goal of a 2% margin of error with 600 people? No, she cannot, okay, because the margin of error is 3.7% if she uses 600 people. So the question is, how many students does she have to survey in order to make this happen? Okay, 600 wasn't enough. So what is it that she really has to have? And this is probably the most algebra you're going to have to use, honestly. So let's use that same equation from up above, but now we're going to make the margin of error that 2%. We're going to leave everything else the same, except we're going to look for n this time. So instead of 600, we're going to just say n. What is the sample size that we have to have? All right, so the first thing you're going to want to do is get rid of that 0.196 because we're trying to get to n, okay? So what you're going to do first is divide both sides by 0.196. Okay, I'm going to just write the kind of the step out to the side there. So when you do that, and you do your 0.02 divided by 1.96, you get 0.0102 and a whole bunch of other numbers there. Keep all of those, okay? Don't get rid of them. Then what we want to do is to get to n, we want to get rid of the square root symbol. So what you're going to want to do at that point is then turn around and square both sides. Okay, so square both sides. So we'll have 0.0102, that whole number squared is 0.325 times 0.675 over n. Okay, I'm not going to necessarily write down what that value is right at the moment, although I will tell you it's like 1.04 times 10 to the negative fourth. Okay, now what you would do next is kind of cross multiply. So this is over a 1. If you cross multiply, you'd end up with that 1.04 times 10 to the negative fourth times n equals the 0.325 times 0.675. So again, I'm going to write this out in a way that I don't have to do all of the work longhand. Okay, but essentially what I want to do then to get to n is I'm going to want to divide both sides by the 0, 1, 0, 2, etc. squared. Okay, so on my calculator, what I've done so far is I've done 0.02 divided by 1.96 and I hit enter. Then I hit the x squared button and I hit enter. Okay, then what I'm going to do is type 0.325 times 0.675 divided by, and I want to pick up this number, okay, that value, that 1.04123, etc., times 10 to the negative fourth. I want to like copy and paste that number. And so if you hit second on your calculator and then the negative button, which right above the negative, it'll say ANS in little tiny letters, that's copying, pasting that last answer into your calculator, and you will get that N is 2106.8775. Okay. That tells you how many people we need to survey. And one note here, you're going to always round up. Always round up. Okay, because even, and this normally would round up, I understand that, but even if we got 2106.2, if you do 2,106 people, that's not enough. So if she wants to have a 2% margin of error with a 95% level of confidence, she needs to go talk to 2,107 people. All right. If she wants to make a 99% confidence interval with a 2% margin of error, the only value that changes from the example we just did is our Z sub C value. Notice that for 99% confidence, going back up to what I wrote in part C, that Z value becomes 2.576, and you go through the same set of steps. So what I'm going to do is go ahead and pause the video and write out the calculation like in full, and then encourage you to do it yourself, and then come back and check and see if you got the right number of people. I also want you right now to use your intuition. If we want to be more confident, should we be asking more people or less people? See if your intuition here is right. So hopefully your intuition said, I want to have more people, okay? You want to be more confident. You need to go out and ask more and more and more people. And I've got the work, again, sketched out. So replace your Z sub C value with the 2.576, and you walk through the same set of steps. So first divide both sides by 2.576, then square both sides to get rid of your square root. Cross multiply. Again, I'm not writing out what 0.0077, etc. squared is. Just leaving it that way. And then doing the 0.325 times 0.675 divided by second answer on your calculator. And always round up, okay? If you need 3,639 and some more people, even a partial person, you have to round up. So 3,640 people would be necessary in order to achieve her goal. All right, that is the end of section 8.2. So go ahead and tackle that homework, and I will see you back for section 8.3, where we'll be doing the same thing, but instead of proportions, we'll be talking about means.